see my screen, right? I hope yes.
Yes.
So let me introduce the new um, advanced uh, course items that we need to go through. So first thing that we'll be talking is the MVVM architecture. Okay. Um, So basically, on the previous code section, we just playing around basic Android or iOS components, even Flutter for example, React Native, whatever the frameworks or applications that we develop. We just develop to get an idea or what to get an uh, basic understanding of how and what sort of things that is available, what sort of things are not possible, to get an idea on basically on the things on a mobile platform. But uh, as we progress, we know for sure that that kind of code, that kind of coding patterns that we have done is not gonna survive in industry level, or at least application that is sanely maintainable. Okay, we can't have everything like we call the coding style that we did as spaghetti codes, because the coding that we did, everything is one single ball of spaghetti. That class is connecting to that one. We are getting data from uh, HTTP services, or we are using retrofit services directly within our view. That kind of thing. Of course, for a small application, if say for example we are getting a number from the internet and we are showing it in an activity, that might work. Okay, but in real world, or in an application that we're going to be developing for the public or a mass use cases, this architecture will definitely fail without any hesitation. Okay, the problem is we don't have a proper way. We don't have a proper way of communicating with each other. So to avoid these kind of problems are not something new. Okay, uh, industries or groups, they start project by simple means. If they want to get something out to the market, they will just use the spaghetti code, and um, they will develop something. But as time progress, maintaining these things will become eventually hard. So people, what they do is they find a workaround for these things, uh, and they publish these things. So MVVM architecture is one of the architectural patterns that emerges throughout last few years. And of course, there are other architectural patterns. The architectural patterns define set of rules, how you're going to organize your code, how you're going to define your application structure. And there are set of things you do and set of things you don't do if you are following this architecture. Likewise, there are several guidelines which will allow us to architect an application. So MVVM is one. There is MVC and there is MVP. All those things have different way of communicating with each other, communicating of organizing the application. But unfortunately, we can't say directly say, okay, MVVM is the best one, MVP is the best one, MVC is the best one. It depends. It depends on the people who are working in the application. It depends on what sort of uh, knowledge or capacity the people have, and uh, based on the preferences of most of the developers out there, it depends. The architecture pattern depends. But most of the time, when we are developing an Android or iOS application, or even Flutter application, MVVM architecture seems to be working fine, even though there are several iterations over it. There are several changes or several different way of doing that. The main concept behind MVVM architecture remains same. and we do a thing called separation of concerns. We will see in a little bit. And remember, when we are talking about MVVM architecture, it is not something something binded to Android itself. You can have the same principles, the same MVVM architecture pattern in an Android application or in iOS application, Flutter, React Native, whatever the application that you're gonna develop. So it is a concept, but how we implement that concept within different frameworks, it's differ. Okay, so we can't expect all the tools or all the functions that we are using in MVVM architecture within an Android application is going to be the same to a iOS application. That's not going to be the thing, but the concept it is going to be same. The way we are implementing, the way we separate the concerns, it's going to differ from platform to platform. The way the naming convention can be different, the organizational structure can be different. You can keep things same, but depending on the coding style, depending on the framework, the naming can be a little bit different. Okay. First, we will understand what is MVVM architecture does. We will apply one in a real life application. Then we will code that application in Android, of course. Then what we will do is we will port the same application, or we will try to achieve the same thing within iOS application. So we know, okay, we can keep the same architecture pattern, but implementation on different platforms can vary, but everything is connected in an architectural way. So we have the concept around it, but the things most matters in a framework is not to know what tools to use, at least what sort of places you need to be, how to architect the application correctly, how to make sure the data flow is not breaking or you are not violating anything with the architecture. So as long as you follow the architectural pattern and you don't violate anything, MVVM architecture can be applied anywhere. Okay, so MVVM definition. So as I mentioned earlier, in here, make sure this is an architectural pattern that is enhances on separation of concerns. Okay, separation of concern is the one most important thing with this MVVM architecture. Most of the architectural patterns, they tend to solve the separation of concerns. Okay, so with a spaghetti code, the problem is everything can be found within a one single file or two files. Maybe they are not connected correctly. So that is not how a big large scale application should work. So we always need to separate our concerns. Okay, for example, it's not related to MVVM at least, but when we are developing object-oriented programming, okay, we have the concepts called abstracts, we have the concept called inheritance. So by following these concepts, what we are trying to do is we are trying to make a barrier between dependencies on the classes, or we are trying to implement new um, uh, we are trying to implement new relationship with classes. Okay, as long as we can make things separate and work on their own, and we can maintain those things separately, that would make our life very easy. Okay, so MVVM architecture pattern is also approaching a way where we separate our concerns, and by separating our concerns, it's allowed to user to have different part of the application as different components. Okay, so MVVM has the following layers. Okay, first one is the model, which stand the first M, and there is VM. VM stand for view model, and view V for view. Okay, so first M stand for model, second V stand for view, and VM stand for view model. So these are the components that we find in the MVVM architecture. So we'll discuss what is a model, what is a view model, what is a view. So these are the three basic components in MVVM architecture, and the interface. So whatever the things that you will see within an application, we call that as a view. Okay, whatever we see, a button, or an input, or a text, something that is something you can see within the screen, we call it view. Okay, so we call these things as user interfaces, and so on and so forth. And there is the concept model. Okay, model is the representation of business logic in the application. So for instance, what happens if we click on a button? Okay, what happens when we enter an email address to a text field? What happens when the server is sending data? What happens if the servers fail to send data? So that kind of a business logic is where we keep the view model, sorry, model, where we keep all those business logic. Okay, so view has the interface, model has the business logic, and the view model is like the middle guy, and the view model is a place where we bind the view and the view, we bind the view and the model using the view model. Okay, so we can consider the view model as a bridge between those two, model and view. So view model is one of the interesting part that you will see. View is what you see, model is the business logic, view model is what glues these two things together. So so pretty easy, right? We have three separation layers. What we need to do is, okay, everything we do, we put in a view. Everything that we have to do, we put in a what is the logic, we put it in a model. And whenever we want to connect these things, we will use the view model to make this bridge. Okay, seems easy. But there are certain rules that we need to apply if we are going with the MVVM architecture. So especially even though we can get things get these things into a separate layer, what will happen is there are certain rules come along with this view and view model implementation. Especially remember the data flow. Okay, where how these things are each communicating with each other matters most. Okay, let's see how the MVVM architecture is gonna look like in an application. Okay, so you can see there's the view, and there's the view model, and the model as a whole on the bottom. So you can see the view can be in the UI or XML format, and the view model is the intermediate. We can use RX Java, live data, or whatsoever. We will look into these things. And there is the model. Model contained in two varieties at this application, where we call the repository pattern, where we can have a local storage or local data, and remote storage for remote data. We will see how we can connect each and every one in this application, how we can define these things, and how we will use these things to make the data works. And one important thing that you guys to see in here is the arrows that is pointing to one layer to another. Okay, you can see that there are arrows without dots, and there are arrows with dotted heads, dotted lines. Sorry. So um, the arrows without dotted lines represent a direct action. Okay, so view can invoke a direct action. We call these things as UI events. Click of a button, typing on the keyboard, adjusting progress bar, clicking on a checkbox, whatever the interaction that we are doing with the UI, we call these things UI events. We call these things as UI events. So based on those UI events, the view model acts. So view send UI events directly to the view model. Okay. So view is sending UI events. The view model, what we'll do is based on that event, okay, based on that event, they will send request for the model. Okay, the model layer is then communicated or connected by these UI events. There can be UI events which won't trigger any repository, but I'm talking about in a common flow where any UI event comes in, the view model can interact with the view, interact with the model, and the model, what will do is it will receive data either from the local storage or either from the remote storage. Okay, so they will trigger these events which are shown in this arrow. Okay, but remember, when we are triggering these events, the response, what should happen after that button click, what should happen when we check on a click box. So that kind of things, those kind of events are sent back as observable changes, or not a uh, direct interaction with the application. That means, so when we are doing this local storage, when we are invoking this receive data call, okay, within the same function, we are not responding back to the view, but instead of that, we will invoke a function which will reactively send some data to the repository. So we invoke receive data. Once the data is received to the local storage, it reactively sends a data to the repository. Same goes to the remote data source. When we request something from the remote data source, it will reactively send some data to the repository after it is done. Okay, so we are asking something and we are not expecting the call right back on this arrow. If it was the case, the arrow should have a double-headed arrow in here. That means we are calling it and we are receiving it. But remember, in MVVM architecture, the data flow is unidirectional. So when we invoke something, we don't expect data to be received that instance, but in reactively, the repository will, the remote data source will send it to repository. Then repository reactively send observable model change to view model. View model will, if there is any interaction to be communicated to the view, they will send these things to the view model. Okay, so this is like the basic architecture for a MVVM architecture. And also remember, when we when we are doing such a things, it is not always the case that view should view uh, when we are triggering an UI event, the view model should sure the view model will receive that, but it's not a necessary case, or it is not always the case that you should always go to the model and get some data. Okay, some calls are there where you can mitigate or you can handle from the view model side. So once the UI is triggering some event, you can directly send that any data, observable data, back to the view. So the whole cycle is not mandatory. But when we are explaining the whole architecture, this is the possible way of going data. So UI can send view model can repository will ask the local data source, then local data source reactive send it to repository will change the view model send to the view. That is like the whole flow, okay, but it is not always not the necessary, it is not necessary that the view model should always do the same. Okay, it's not like 100%. Okay, the path is always you should go to the view model and the model you have to get it back. No, it's not. Sometimes the view will send something to view model will reactively send something to view. Okay, that can also happen. So what will happen in here? Um, the MVVM architecture has this um, good distinct or good layering system that will eliminate a lot of the errors that we will find within our application. Okay, we'll go into what are the advantages and disadvantages of MVVM architecture while we are practicing these these arrows, what they are meaning. This is like a representational view. Okay, don't expect your code to have arrows, but this is how we can visualize the data flow within the MVVM application. Okay, all right. So let me do one more thing. Let's talk about benefit of using the MVVM pattern. Okay, I'm not saying MVVM will solve everything. Okay, we have a spaghetti code, and by using MVVM, we can resolve all those things. So no, that is not the case. Okay, but we have certain benefits. We should take advantage of that. If there are any disadvantages, either we can mitigate that, or we have to find another architecture pattern that suits us. But believe me, most of the time MVVM will help and resolve 90% of your problems within your application architecture. Okay, so let's go one by one and try to understand what they are meaning and how we can take the benefit of that. If they are in an existing model implementation that encapsulating it in within, it is difficult or risky to change it. In a scenario, in the view model, act as an adapter for the model class and enables you to avoid making any major changes in the model code. Okay, so what does this mean? That means, so we have this separated sections in here. The view and the model are two different layers now. They are not binded or glued together as a single entity. So for example, let's assume that for this instance, we don't have a view model in the middle. We just have the view and the repository. So we call the view and we get the example that we did last time within our basic introduction course. We did exactly that. We had a view, we had a repository, which was, if I'm not mistaken, retrofit API. We just call from the API, we call from the UI to the API, and we get bunch of JSON values, and we redirect back to the view. Okay. So the disadvantage of this is, say for some reason, the model has changed. The API response that we are getting has changed. Okay. So what will happen in that scenario? The view is expecting, let's say, let's take a hypothetical example in here. So we had a simple task where we show a list of users where it has first name, last name. Okay. And when we bind that view, of course, it's fairly simple. The view will, we want to show some data. So in the initial call, what we do is we call the retrofit API, and we get a list of usernames containing first name and last name, and we bind that view in the XML. So we have a list view, something like that. Then we can show this list of views without an issue. But for some reason, the model has changed. The API has now changed. They are changing um, first name, last name to full name and middle name. Okay, for some reason, they are changing the API. So the repository is changing. The repository is changing, but the view is not aware of that. The um, view is expecting first name and last name. Now the repository is giving full name and the middle name. So whenever we are calling the API and when we are getting back the values, it is two completely separate things. We are asking first name, last name. They are sending middle name and full name. So immediately what will happen, this will break the view and the repository. Once we get the request, that is gonna crash. Okay, the data has changed. But what if we have a middleman in here? Okay, we have a middleman in here. What will happen is the view is asking for the users list, and the view model is gonna ask that data from the repository, and the repository, of course, it is updated now. The first name and last name is no longer there. They are sending full name and middle name, and they will not directly communicate with the view, but for the view model. They will send the data to view model. So view model act as an intermediate, and the view model will get the data, but the data is not compatible with each other. So they have changed the values. So what will happen is view model will not send any data to the view, and the application still works, but data is not there, because we obviously we need to change the view model. The binding that is done in here should be changed, but the app won't crash because we have a middleman in here. It will take the blame on the API or from the view, and it will mitigate the crashing. Okay, so what we have in here, the middleman will come to rescue. The app will be not crashing immediately. Okay, we can fix it, and we can change the view model, and we can easily fix the problem that we had on model changes. So whenever the model has changed, okay, if we have a direct connection and we are trying to implement the view as a direct connection to the model, application will definitely crash. But if we have a view model in the middle, view model will try to suppress that error, but still show something in here. Okay, so the having a middleman can mitigate application crashes in the first start. Okay, so that's what we are making, improving the encapsulating the business logic. Okay, so we have this business logic in the view model. The view model will take care of that. If there is any changes, if there is any issues with related to the view model or the repository, we can suppress or we can change it in the view model. But the app caching rate can be drastically reduced. We will see those things in real action. The next thing is developers can create unit test the view model of the view model and the model without using the view. The unit test for the view model can exercise exactly the same function used by the view. Okay, so this is one of the huge improvements or huge plus point that I see in MVVM architecture. Now you guys know that when we are doing a unit test, okay, and we are trying to write something, when you're trying to execute some test cases, of course, we say, for example, we don't have the view model in the middle. We have a view and a repository. Now we want to check when we are executing some command, the business logic is acting correctly. For example, let's say we have a view model which do a simple calculation. Okay, we get two numbers from the view. We will get two numbers, let's say 5 and 6. And the view model, what it does is it will make the addition. Okay, so we will get two numbers to the view model, number 1 and the number 2, and the view model do the calculation. It will put it, let's say, 5 plus 6 and 11. It will send back the data to the view. Okay, now if you look at the view model has purely only the business logic in here. Okay, it's not associated with the view, it's not associated um, with repository. When you are executing your business logic, you can purely test view model as it is testing by this view model, by this view. Okay, so view does not need to be loaded when we are testing the business logic or when we are testing the view. Same goes to the other things. Each separate layers, the view can be tested individually, view model can be tested individually. If you want the repositories, those things can be tested individually. As long as these things are not connected to each other, as long as the direction of these values are followed by these unidirectional flows, it's going to be really easy to do the uh, application testing. Okay, so we'll see these things in action. For now, just remember, by having these separations, the view model can be easily tested apart from the view or the model. Okay, business logic and other components can be easily testable. A POI can be redesigned without touching the code, provided if the view implemented entirely in XML. There's new version of view should be the existing view model. Yes. So, for example, we have a view and we have a view model. So, anytime if you want, we can take this view and remove it and implement a new view in here. The best example that you would see these days is if you have a traditional XML based Android application. Now we are going to implement this in Android Compose. Of course, if you followed MVVM pattern correctly, you can definitely remove the view which is written in XML and plug in the um, compose based component in here, and it should work as expected. There should not be any major issues. Of course, there's going to be like implementation changes. There can be different application level bindings that we need to modify. But other than that, it should work without any huge hesitations or huge drastic changes. Okay. But if we did not have the view model in the middle, what will happen is it's not going to work as we expected because of we are solely depending our views with the repository, and we can't expect that to work. So binding, separating these layers each one by one, give us the upgradability to the application to the latest views. If you don't need the view model, we can also change that. If you won't need the repository, we can change to some implementation. The application should still work because these are totally separate layers, and they are communicating reactively. So as long as you do the architecture right, you can easily swap between either one of these implementation, and it should still work. Okay. All right. Designers and developers can independently concurrent their components during the development process. Design and focus on the view, while developers can model and the model components. Yes. So if you are in a large corporation, okay, and if you guys have many resources to work with the application, there are certain things that you can divide upon. For example, the view. There is one single person who is really good at making XML or Compose-based UIs. Okay, he or she can focus on building the views without an issue. Okay, the only thing they need to do is take the design concept and design XML view or Jetpack Compose view. They don't have to think about anything with the view model or repository. How the data is coming, they don't have to care about that. As long as they do the view and as long as they have a connection to the view model, that's it. And most of the time, the view model and the data repository is something that there is communicate with the other developers. So let's say, for example, someone in the team is really good at making view models. They can mainly focus on view model and the repository and everything. They don't have to think about the view itself. As long as they are receiving events and sending the data reactively, you don't have to worry about anything on that side. Okay, so two people can work individually within the same application without depending on each other. You don't have to say, okay, I need that, I need this. As long as they are following the MVVM architecture, one will create the view, another one will create the view model or the model. People can collaborate really easily when we are using the MVVM architecture. That's like the whole point of when we are working with huge applications. People can collaborate in different levels. So you guys can see that, of course, it brings us a lot of what do you call advantages, benefits. But remember, this is not, as I mentioned earlier, it's not a silver bullet. It's not going to solve everything for you. MVVM pattern comes with several disadvantages as well. Okay, so we'll see what are those things. First of all, the disadvantage is if you are new, if you are trying to understand a pattern, it's gonna have a little bit of a learning curve. First, there is a learning curve that you need to do. You need to learn the MVVM structure, how these things are working. You need to know about reactiveness, okay, how reactive components works, and such and so on and so forth. So you guys need a little bit of knowledge sharing or a learning curve is there to work with. Okay, of course, if you are directly diving into MVVM, there won't be anything. But if you are existing user, you have done some smaller things, and you want to implement something big, yes, the learning curve is there. And the next thing is, as you guys can see, MVVM pattern uses several tools in order to work with these things. As I mentioned earlier, these things does not come out of thin air. Okay, when you are designing the reactiveness, there are certain libraries that you need to use. That's something different from framework to framework. You can't use RX Java as it is in a Swift UI project. Okay, you can't use Kotlin Flow as it is in a Swift UI project. There are certain things that you should know depending on the platforms that you are using, depending on the framework that you are using. The concept is there, but how do you glue these things together? How MVVM architecture works with each other, how they interact with each other is different from one to another. Okay, follow the same pattern, but the way they are coded or they are doing the work is different from one to another. So you guys need to learn all about those things in order to work. Okay, so that's a technical barrier that you guys have. And the other things are patterns. Okay, these, even though this is like single this is an implementation, not everybody is agree upon these patterns. Of course, the basics are there. The repository, they can have a one single remote repository, they can have only one local repository, or they can have third-party repository, third repository, and they can use different frameworks for these things. As example, the repository can be developed in using retrofit, or someone can use some other library. That's kind of, it's kind of vary on what we are trying to achieve. So MVVM architecture is there, but learning curves for each and every component, each and every framework, it's take a little bit of time. That's why we don't introduce these things as a first thing for introductory to mobile application development. You need some clarity on how these things works, then you need to progress on. Okay. The other things that I have mostly seen with MVVM architecture is that reactiveness. You guys should really pay attention to these arrows. Okay, the arrows meaning arrows have a significant meaning. If you do not understand what they are doing, the reactiveness, observable response, observable. Okay, you can't directly call uh, from a view model to a view. No direct connections. You can see only the direct connection is there from view to view model, but not from view model to view. Okay. I have seen several projects. These basic concepts are violated. Okay. If you violate this unidirectional data flow, for some reason, there are the main reason people give is we found a code example that has done this and we were following that, but that is wrong. It's not always the case. You should have, of course, it's okay to get some coding examples. Everyone does to get from internet, but always make sure you follow these patterns. Unless if the code is violating one of these patterns, the unidirectional data flow, find another alternative or get the inspiration from that code and do it in the right way. So do not violate this directional data directional flows. It will work, of course. It will work, but it defeat the sole purpose of having MVVM architecture in the first place. So do not violate these things. The violation can give you more headache than you are going with a small patch. Okay, so that's about the basic of MVVM. We will jump right in to a small code of example. In that way, you will get more inside of it, or you guys can see it in action rather than showing these things. I think I have Android Studio in here. Share my screen. Android Studio. I have, I think, your old application, if I'm not mistaken. Yeah, but anyhow, we will create a new application. We will create a new project. Okay. And yes, we have a basic of it. There should be an MVVM example in here. Responsive. Yes, there is the fragmented view model. There are also yeah, let's go with the fragmented view model. I'm not gonna go with the basic what we are expecting from here. Just gonna go. I assume you guys have followed these things. So if you not follow the previous course, I have explained everything in here, right now, what I'm gonna do is I'm gonna use the code as it is. Okay. That is Chrome. Okay, Chrome in here. I'll use the same application number, otherwise I'm gonna keep forgetting. This is 2023. Okay, I'll just use a dummy one, Kotlin. Okay, it's gonna do. I don't need anything else. I will just finish. So you guys can see the Android Studio, right? Popping up. No? Okay, I think I might have to share the whole screen. Give me a second. I'll close this one and got it. Share my screen. So basically, I just created a small application. Nothing, nothing out of ordinary. We just create an application. We just gave the project name and went with the basic application creation. If you miss the file creation part, I just went to file, new, and went to new project. And in here, I have selected fragment plus view model. That's it. And I just went with the default values that we are getting here. Nothing special about it. That's it. Okay, still Android Studio does it works. Let me look at the project structure. Okay, I have the project in here. Let me go to the package view. That would make things easy. My system. Let's see. So I'm not gonna go again with these um, patterns in here as well. As you guys can see, we know what Java, what REST, what's main Android test. We have covered these things. So if you guys can't remember, again, have a reference to the all the lectures. You will get an idea what these things are. Okay, let's go with the main activity. So the simple application that it's created. So in here, you will see we have on create function. And by the way, we will be using XML based one, but from after one or two lectures, we will be going to utilize the KNM, and we will be changing our implementation from XML based to Android Jetpack Compose based. So for now, we just look at what we have in XML view. So we have basic application. We have on create method. On create, we are setting the main activity, the main layout, and save instances. We are creating the container with the main fragment, and that's it. Okay, a simple application. So if you look at the activity main, if you got the resources, layout, activity main, it's going to be a simple host container for our fragment. That's it, as I'm expecting. Still loading. Okay, let's just give it some time to refresh. And meanwhile, we'll go to the main section. Okay, so you guys can see clearly in the application that we have created. Since we use a template, we are seeing predefined class in here, predefined package or package in here. that is called UI, which isolate all our UIs pages that we will be seeing. For now, we have only one UI, which is called main. Okay, so main activity is where we start things, and the main UI is the place where we have all our UIs in place, and it has a main UI in here. And if you go to here, you will see two different files. One is called the main fragment. The other one is called the main view model. Okay. A, so main is the page. Okay. Main is the view that we are going to see. So since it is going to be a fragment view, we will call it main fragment. Okay. And since it is a view model that we are having, it's going to call the same view name and suffixed by view model. Okay, so for example, since this is the main, the view file is called main fragment, and the view model is called main view model. So if we had another class, another page that we want to say, for example, let's say settings. So the naming convention is setting fragment and setting view model. Okay, that's like the way we are uh, we are arranging this icons file set, so it's easy to anyone to understand. And notice here that we only have view and the view model only. So we don't have a model in this scenario. That is completely fine, as I mentioned earlier. You don't need always to go through all the way down to view, view model, and model. It's not always the case. Since this is an example, the the program does not have all the information. Since it is going to give us a scaffold basic application. In this application, you will only find a view and a view model. But later on, we will implement view model as well. Okay, so model as well. Right now, we do not have a model in this example. Okay, let's see what we have in our what do we have in our main fragment. So it's always surprising to see that whenever I do start a lecture series, they almost every time have changed the things that we need to do. It's always updating. So I might need to go one more time in this view, and we will see how we can get on it. So we have a fragment. Okay, we have we have a fragment called main fragment, which is extending the fragment class. Okay, that is something we know already, which is coming from the Android X fragment section. And we have a companion object. Companion object is like static class if you are coming from Java word, and it is creating a new instance of main fragment. Okay, and we have instantiate the view model. Okay, we have a private late init variable called view model, and the view model type is main view model. Okay, so if you guys can remember the arrow itself, you have a link from your view to view model. This is the link. Okay, so you are in a view, fragment is basically a view. This fragment is something that you can see, view. So view have access, view can call anything within the view model. Okay, the view model in this scenario is the main view model. So we can initiate a direct connection. Remember the data flow, the direct connection in the view model. Okay, and how do we initiate? You can see that is not initiate right here. It's gonna create on create method. You guys can remember the lifecycle methods of a fragment. First of all, it will create the super on create method. Then we're gonna be initiating the view model. In this section, we have the view model. right around here. And how do we initiate a view model? We have this helper class called view model provider. It is something coming from Android X lifecycle. So using this view model provider, and who is the owner of this application? It's going to be this. That means this context is the responsible or owning this view model. And we call this get method and provide the main view model class. So remember, when we are creating this view model provider on this context and we are calling the get method and getting this view model out of it, this is a place what we call a singleton view model provider. That means whenever we want to inject this view model to another view for some reason, you just have to call it by its class name, okay, Java class name. So this is going to be a singleton throughout the application. As you can see, it will go to the view model provider and get the instance of that view model and inject in here. So the view model is injected or provided by this simple line of code view model provider. Okay, so we just have to pass the context and what is the view model that you want to take. Okay, as I mentioned, you can inject this view model in another fragment as well, but there is also what you call an anti-pattern. You interact with the view model only once. Let's see how we can get a way around that. That means you don't inject the view model everywhere you need to access something. Okay, we'll see. We'll see how we can communicate with view model to view model in advanced sections. Right now, remember, you can use the view model provider to inject a view model into your application. Okay. Okay. Just to make sure, I will run this application. Okay, let it run. Okay, and on create view, where the view is created, okay, since this is a fragment, we have on create view, and we're gonna use the inflator to inflate the main fragment main. In here, it's gonna be just a simple main fragment text. Okay, that's the only thing that you will find in this application. Nothing more, nothing huge is going on here. So we have a main fragment in here, okay, and the main fragment is inflated and put it in around here. Now we have a view model. Let's go and see what the view model is. No, do not get surprised that this does not have anything in here. So it's basically a class called main view model, and it is extending the view model. Okay. Now you guys can see a clear picture on the view and the view model. Take a look at this. Take a look at this very clearly. The view model does not have any reference to the view. As I mentioned earlier, that should happen reactively. So you guys won't find, if you guys finding anything uh, from view model, sorry, from view to view model, that is okay. That is something that that's the view model MVVM architecture allows. But if you see uh, view model is calling some view, okay, it's a view, not a model. But if you are calling a view within the view model, then that is an anti-pattern. Okay, you do not want to do that. If you are doing that, then you are doing something wrong within the MVVM application. Okay, so make sure you have the view and you have the view model. View can have a reference to view model, but not the other way around. The arrows, remember those arrows? Those arrows represent something. So you guys have to be very careful on that. Okay. Uh, let's see. Any questions up until this? This is like nothing at this moment because you guys have been working with a lot of applications. This actually tells us nothing sort of things. Let's see whether we can run this application. It should say just main fragment. That's it. Okay. So we have the view and the view model, but it's not doing anything at this moment. We just have two small classes. That's it. Okay. So any questions up until this? Anything you guys need to know regarding the MVVM pattern, the theory behind it, anything that you guys need to know? Just let me know now. Okay. Do you guys have anything with that? Okay. Hope since this is a not a huge thing, you guys can understand really easily, not that much of complex within this. Okay, let's do a small change it in our application. Let's see how we can interact with the view model from the view itself. Okay, so we have a view model, but how we going to interact with that in the first place? How we gonna make our view model interact with each other? Right? So that's pretty straightforward. As I mentioned earlier. Um, Simply, you guys can't use anything with related to um, uh, without working on these things unless you use reactive components. So you have to have reactive components in order to work with these things. So let's create some variable and let's try to interact with that within our application. Okay, where we can start? We can simply create what do you call simple variable, and we'll show it first. Then we will go with something more advanced. Mm, mm, Give me a second. Dun, dun, dun. Uh, File open. I have a project. Let me find it. I have it somewhere. Mm-mm. Okay, let's create a simple user observable, and we will see how we can provide that in our applications. It's going to be a very simple one. Let me check. Is that... Okay, let's create a few variables. Let's start with something really simple. So as I mentioned earlier, so whatever the options, whatever the data that we need to do, we have to put it in our view model. Okay, so if we want something to be shown in our application, the business logic, all those kind of things should be uh, within the application business logic. So we don't put any logics. So for example, any calculations that is going on here, anything that is done within the application, we do not put those things in our UI or the fragment. In this scenario, we do not put that thing in our application. So what we'll do a uh, simple application uh, which will be using uh, view model in this scenario. So uh, we will go to our view model, and we will have a variable called let's say result. Okay, and the result is going to be a mutable uh, mutable double mutable live data. Okay, mutable live data. Okay, the type, it's gonna be, since I am gonna be doing a simple addition in this scenario, I will just call it I'll have the type of double. Kotlin, do we have? Yes, double. Okay, and what's happening in here? We have to initiate it, and I will go why this is mutable double data and everything later on. For now, we will have a simple addition function. So we will call a function called add, and it will give me two numbers. I'll say number 1, and it's gonna be, let's say, a double, and I will take number 1 and number 2, These are the two variables that I'll be interesting and I'll be working with. And I will have the numbers value put to the result after I do the addition. So I can do let, sorry, not let, I can say, what do you call that, var underscore result, and I will call these number 1 plus number 2. Okay, and what I have to do is now result dot value equal underscore result. Okay, so now we have something small in here. We have this add function which will take two numbers and have the result in here and put it in the result over here. We can just reduce the number of lines if you like this. So whatever the addition these two do is gonna get in these two is gonna get addition and put it in the result. But remember, it's not directly putting in the result, but rather than result value. We'll see why this is the case. For now, we just have it like this. Okay. Now, if you go to the view itself, we don't have anything that will bind these things at the initial press. So what we'll do is we will show that within the UI. Okay, the UI itself is a simple fragment. It's the main fragment. I need the okay. This is the fragment that we are interested in. It's just saying main fragment. Let me go to the code view, and it has the ID of message. So I'll be utilizing the same thing, but I will make sure that I have binding enables, so I don't need to do a lot of view model bindings in our application, or I can just simply call find um, view by ID. It's not find view by ID. If I want to find view by ID, I think I need to enable lifecycle binding. Just let me double check whether I have enabled package project. I have to go to settings, right? If I'm not mistaken. Build.grade. I had to go to the pack Android view. Makes easy. App module. Do I have binding enables? No, right? I need to make binding available. So it's easy to do the bindings with the UI. I think we have covered this in our older version. I'm not sure, but in order to use the bindings, I will just say this in. Let me check Android binding. Data binding. Okay, under Android here, I have to go build features. Do I have build features? No, we have to have build features. Okay, changed it. Not sure. Data binding. Data bindings. Okay. Um, Seems to be I have changed it. Let me check. Features not here. Basically, on the build feature. Am I doing something wrong? Okay, let's go with simple version then. It's gonna make things easy. We can use main fragment. And context. This outline file ID. Okay. Sorry. Need to do it in on create view because it's not gonna work. Activity by view by ID. Okay. I have to do it using the activity reference. Dot ID that was called message if I'm not mistaken. Sorry. Find view by ID. Its type is gonna be what was it? It was a text, right? Text view. Text view. Find view by ID. ID is r.id.message. Okay. A session. We'll call this let var message. Okay. And we can say message dot text. Text equal, we'll just say one for now. Yeah, did not check. Okay, message is, if the message is not null, I'll just set run for now. Let's see whether this works. Let's see now. Go to emulators and play. So we just did not take any values from the view module itself. We just It's not in the inflated. On create with view. View. I think I have to create these things. What is this? On create, I have the ID. We sorry, I was referring activity, but it should be view since we are creating the view itself, and it's just showing Randika. That's basically what I did was I did not have anything in here. So what we can do in here now, rather than having these values statically put in here, what we can do is we can use the view model. Okay, and we have the result, and we can have the value. That's the basic thing that we're gonna do. Okay, we'll just go around here and we will make it to string because value is in double and I have to make it string. Let's see whether this works or not. Well, unfortunately, it is saying null in this scenario. That means we don't have any value. Is that true? We go to the result. As you can see, the result in here, mutable data in double, and we did not provide any values. It's not initiated with any value unless we call the add function. But can we do something about it? Let's put a double value in here, and let's say 1 in this scenario for demonstration purposes, and see whether it works. Yes, now you guys can see. I'm not sure whether it's 100% clear at this moment. Yes, now I have put something called what we call a default value for the result. So unless there is no value defined in here, the default value is taken. So I would say 2 in here and I would run it again. What will happen? It's going to show me the default value that we have put in here. Okay, it's not going to show anything else. It's going to just show the default value that we have put in. Okay, so what I'll do next, I will invoke this add method. Okay, I'll just invoke the add method and see when we're invoking this add method and pass two numbers, it will change the value and whether it reflects on our UI. So let's go and do that. So I don't have anything that is supporting me with a button. So what I'll do is I'll create a simple button in my fragment. Okay, just a simple button on top of here. I would say button, and with I will say match parent and web content. Okay, and I need to have an ID for this, Android ID, and I will say just say add button. Okay, what I'm missing in here I think was probably constraints. I need few more other things like provide feedback on I think I need to have title text if I'm not mistaken. I might need to do some constraints. It's easy to me to let me go to the designer view and okay. I will just add some constraint in here. So the app layout button constraint will go to the same location as this on top of ID message. There you go. So these things are two different things now. Now I have the add button in here. And then let me go inside the add button and let's see what we can do about it. View, find view by ID, and it's gonna be a button, and the button ID is ir.id.add button. Okay, this is the ID for the button, and let's say var add button. That's the button that we have taken, and we have to do add button dot on click. Uh, set on click listener, set on click listener, and we have to pass the anonymous one. Set on click listener. Okay. So in here, what I will do is once that I click on it, I will call the view model dot add function, and I need to pass two numbers in here. Obviously, I will choose 5 and 6, right? And to make sure that I am calling this I'm calling this view and I am getting the number in here, I would just make a print statement here. Okay, print result dot value. Okay, that should give me the values that I am seeing. Not sure this locket is set up, but let's see. Let's run the application once again. Now we have the add button over here, and you guys can see that when I click the add button, it says that 11 is print out. Let me log it down. Log what is dot debug message. I would say add result, so I can narrow it down. Result, so result dot value. Okay, we have to make to a string. Result. Okay, so I can narrow it down from the locket, otherwise it's gonna be really hard to see. Okay, I will filter out add result from here. Right, just clean, and when I click yes, you can see that the debug message shows 11, but as you can see in here, the view itself, it is not updating. Okay, the initial value is 2, that is right, and it is not doing anything about it. It's not updating in here. So the reason behind is that if you look at the application right now, if you go to the main activity once again, now you have the message, of course, and we are finding it by ID. if the message is not null. In this scenario, I don't think it is even necessary. Yeah, because we have found it within the view. And the text that we are going to show is coming from view model result and the value to string. Okay, so whatever the value when the view is created in this scenario, when the view is created, initially it is 2, and we can change it to something more prominent. So if I go to view model, I'll just say 0. So the initial value is in here is 0. And now if I go here and we have the r dot, we have the initial value we are taking from the view model result. Result is the variable that we have, and we are getting the value and making a string and put it in the message text. Okay, that's the simplest way that we do. But later on in the application, when we click on the button, we invoke this add method where we pass two static numbers, 5 and 6. Then the result changes. The result changes. How we know for sure the result is changes? You can see that the logging message that I have put in here, where when we call on the add method, and the result value is updated in here, and it is showing in the logcat. But unfortunately, the result update message is not showing within the message itself. So anyone have a theory around it? Why it is not updating? What's the reason? Any guesses with you guys? Why this is not happening? Initially it is showing, but when we change it later on the application, it is not updating. Any ideas, guys? Why it is not happening? Raise your hand if you have a theory. So initially, it is taking the value from the result, but later on we change it using the add function. It changes in the view model, but it is not changing in the view itself. Any reasons for that? Yes. Okay. The reason is that, as I mentioned earlier, the message we are setting in here is the initial value that we have. Okay. The result have been changed. Okay, the result have been changed over the time. When we click on the add button, it has changed, but there is no way the view itself, the message itself, knows that has been changed. It does not know the value has changed in the result. The result has changes, but the view does not know. So what we have to do is what we are doing is simply we are taking the value, assign it to it. Okay, that's it. Take the value, assign to it, that's it. But what we need to do right now, if something changes in the result, at that time, please change the text. Okay, at that time, please change the text. What this says is whatever the value that you have in the result, assign it to the message. But now what we are trying to do is observe the changes. Observe in the sense, if by chance the result has changed for any reason that we are doing, if the result has changed, when that happened, update the text message. Okay, update the text message. That's the thing that we need to do. Okay, that's what we call the observability. Okay, this is assigning. Okay, for initial value, if you are having something like that, this is okay. But if you want to observe the changes, at some point of time, the result is changing. By that time, whenever the result has changes, let me know. So whenever changes have been made, you have to take that change into the view. Then you have to observe that change. So how are you going to do that? View model. dot result, we have the observe. Okay, so we have observe method in here. The lifecycle owner is going to be this, and the observer in this scenario is mutating live data. Oops, sorry. Give me a second. There's a shortcut for this. Observer. The model observer this. Okay. Okay. Other side. Observer. Okay. Can I use this? Not this. You can use view. Lifecycle owner activity. Restart activity. Sorry, restart. Give me a second. Fragment. Life. Fragment lifecycle owner. Lifecycle owner, get lifecycle owner. Okay. We have a method get view lifecycle owner and observer. Now we will say message.text equal it dot to string. Okay, let's see this code works first. Okay, now you guys can see that what happens in here. In I press add, the change has been done to 11. To make things a little bit more clear, what I will do is, rather than showing static number for the first one, I will make it random, so that whenever we are passing the number, it changes. So I'll say math.random. Okay, so it will always give me a random number between 0 and 1. So and I will multiply it by 12. Okay, for some reason. And what I'll do is I'll relaunch the application. Okay, the initial value, as you can see, it is 0. That's because initially the observer is taking the value and putting it in here. If I hit add, you can see a number popping up. And if I hit again, since this value, the number 1 is a random value, it is showing some random values. So the state changes whenever we are changing the view, the result changes. Rather than assigning it to a value, what we are doing is we are observing to that value changes. Now, every time when we are doing a value, when we are clicking the add button, every time the result is getting changes and we are listening it in here. Okay, so rather than using the first initial value reference, what we do is we use the view model result observer method, and the observer method requires two things. First one is the lifecycle owner, who is owning the lifecycle of this view model or the observer. That the reason behind a lifecycle owner is when we observe on something, when you start to listen to something, we should have a place where we stop listening to these things. Okay, the view models, we're going to say, okay, we will be observing any changes that happens to result. Okay, now when we, let's say we are moving away from this view to another view, or we are putting it back to sleep or something like that. Whenever that kind of situation happen, we should say, okay, this view is no longer visible. The view is no longer need to be updated. So what we need to do is stop listening, stop observing. Okay. So we are binding the life cycle owner of this fragment. The fragment has life cycle owners as well. And we are binding the same life cycle owners to our observer. That means whenever the fragment get destroyed, we are stopping our observing. We are no longer going to observe any changes that happens to result while the view is no longer within our life cycle, while no longer the application is working, or the view, at least the view is not there. So we are binding our observers. We are binding our observing. Okay, we are listening to you as long as our fragment is alive. Okay, this is what the observer life cycle owner means. We are from our view model, we are listening to, or we are observing the result as long as the life cycle of this fragment is there. Okay, and what should happen when we observe? So for instance, it is sending a value. Okay, the observable, the result, it is by default, it is called IT. Okay, that's why it is, I can call IT to string. Okay, we no longer need to call result dot value dot to string. The value, it is called it. But if you want something named, you can have uh, named as well, but I'll just go with the IT or it as a default name. So whatever the value that we are getting, and we are putting it in here. Okay, and since IT is a double value, if you guys can remember, the result is a type of value double. That means it's basically not a string. We have to make it a string by calling toString method, and we will show it in the text right around here. So whenever we are clicking this button, the result changes when we are observing to that result, and we are putting those things in here. Okay, now you guys can see when we are adding this, it is going to show in here. Okay, so this is the observable pattern. Okay, this is what we call the observable pattern. Okay, the anti pattern for the observable is we are not observable, but we are retrieving the values. So let me show what do I mean by the anti pattern. So let's have the add in here. Okay, so we will have a function. This is not a valid one. Add anti function, I will call. Okay, this is not a valid practice or nor a good one. Okay, so we can do the same thing, like return number one plus number two. Main model. Okay, we have make it double. Now this function, the add function, and this one is doing the same thing, adding two numbers. In here, we are storing it in the mutable live data. In here, what we are doing is we are getting the value and return it back. Okay, and in the view model, what we can simply do is we can do it like this: view model dot add add anti function. I will say uh, map dot random, and I will say 12 12.0 in this case, and we can have the text message in here and put it in here, but I need to make it to string since it is not a string, and I can clearly remove this one as well. This should work as well. Let's see whether it is working or not. Okay, we have the main fragment. When you click add button, you guys can see the implementation is pretty much the same. What we are doing here is we are on clicking the button, we call the view model, call the add function, we pass in two numbers, we get that number, and we set it as a text message. So this is a completely anti-pattern. Okay, why I am calling this is an anti-pattern? So the value that we need to retrieve, the return of this add anti function is we are not observing it. We are directly calling it, and we are getting the value back. If you guys can remember the arrows, okay, this is a hard arrow from the view model to view. Okay, this is what it looks like in theory. In practical, a hard arrow. But a soft arrow or a dotted arrow, this is how it looks like. This is going to be an observable pattern, and this is the way it should happen. So if you're saying you are using MVVM, but you are using this kind of pattern, this is not MVVM, that is an anti-pattern. Okay, do not use that kind of pattern within your application. You have to make sure you do it the right way with the observable. Okay, you have to do it with the observable. Do not use these anti-patterns. Okay, so that's what we call the reactivity. Okay, the reactivity in this scenario. So anyone can ask, okay, now why this hustle? Why can't we use that the same thing? We have a function, we have written something, and it works. Okay, it works as it is. If you don't use observables, and this um, and whenever you want to work with this, it works. There is no issue with that. But remember, the problems arise when you are trying to implement uh, testing for these scenarios. It will be a mess. Okay, you will find, I will show you guys why this anti-pattern is bad for testing, as well as when we are implementing model. As you guys can see, there is no model involved within this application, because we have view model and the view only. When we involve model into this application, this will break. This will not work. Okay, to make sure we are following all the checkpoints or check marks within our application, make sure the um, observable pattern is used in our application correctly. Okay, otherwise it is wrong. All right, anything up until this point you guys lost, or you guys need any clarification? Please let me know right now. Need clarification? You guys understand what is the difference between observable pattern and direct communication? Okay. All right. Silence means I assume that you guys are doing great. Okay. Nice. Okay. At the end of the session, you guys have to complete an assignment based on this. So if you have any questions, just ask at this moment. Okay. All right. So let me show another anti-pattern at this moment. Okay. So as I mentioned, we have within the view, yes, within the view in this scenario, the fragment, we have access to the view model. Okay. And the other thing that we can do is not have the observable pattern, and we can have a different approach where we can set the values, where the view model in this scenario have access to view. Okay, so have access to view. So let me show one of the anti-patterns right now. So we can remove the observable from here. All right, and within the view model, I have the add button. Let me create another add function. Will name this function add NT function, okay, and I will have the text view in here. I will call just message, since it's the same as name, text view. Okay, now what I can do is when I call the anti function, I have this so many messages here. So when I call this add anti function with the two numbers, I can pass the text view that need to be updated. So what I will do is I can say, okay, message dot text. I can say result result dot value dot to text to string. Sorry. So this is gonna work as well. So I can call the active function. Let me copy this one, and I will comment this one as well. Now we don't need to pass. Sorry, we don't need to set it. We are setting it in the view, but we need to pass it as a we need to pass it as a variable to our anti function. Okay. Now, if you run this application, main fragment, still it works. Okay. Still it works. It's no issues. Why? We are calling the add anti function, a random number 12, and the message text view that we need to update. In here, the anti function, it does the same thing. It adds those two numbers and set the message. Since we are passing the message from our view to the view model, we can access the text from here, result dot value to string, and assign it to the text dot message dot text. Same thing, it's working perfectly. But what is wrong in here is that we are doing first anti-pattern. Why? We are not observing the changes for the result values. Okay, we should always observe those values. Okay, right now what we are doing is we are sending the text view to our view model, and we are updating it on the go. So why this is an anti-pattern? Within the view model, we are having some view components. Okay, so we cannot have these view components within our view model. That is also not correct. So we have to make sure the view model stays clean as possible from the views it is interacting. Okay, the view should not have any interaction with the view it is calling to. Okay, so this view model has interaction with the text view from its fragment. Okay, so this text view is referred within the view model. So that is why this is called an anti-pattern. You cannot have anything associated with the view within the view model. Okay, so this is also an anti-pattern. Do not try this. You can try, but it's gonna make you what do you call a bad MVVM programmer. So you are violating MVVM architectural patterns. So you don't you should not follow those things. So these are like the common mistakes that I have seen throughout the beginners. They since the code is working, they are going ahead and find they're trying to make it work, but unfortunately, when it is time to test, when it is time to isolate things, this fails horribly. Okay, that's why we cannot have these things within the application itself. As you can see, the view model should be clearly separated on each other. Only communication happens by unidirectional. View have access to the view model, but view model does not have access to any components in the view. However, whenever we want to communicate something from the view model to view, we have to use the observable pattern in order to retrieve that values. Understood? So this is the basics of MVVM, and you guys do not want to mess this up. Okay? All right. So is this clear enough for you guys? Any clarifications needed on any part? Raise your hand, please. Any clarifications? I am a bit doubtful on this scenario. I am a bit doubtful on this section. Please let me know so I can clear it out. All good? Okay. I suppose everybody is having a good idea on this. Great. Let me go to setting. Do I have the dark mode thing? I'll make this one as dark as well. Dark theme. There you go. Emulators looks good now. Okay, so we have the application, we have the MVVM architecture. Basically, this is like the basic thing that you can do. Now, for the assignment that you guys need to do, okay? So it's going to be a simple assignment since you need refresh your memory and you guys need to implement MVVM architecture with the basic stuff. I would recommend a simple calculator. Okay, the requirement is a simple calculator rather than we are getting two random numbers generated. All you have to do is have two text input fields right around here saying number one, and the second one on right bottom of that say number two. So we have two text input field, number one and number two, and on the bottom you will have a simple uh, four buttons for the basic mathematical operations: plus, minus, multiply, and divide. Okay, so you have four different buttons on the bottom. So if I put 1 and 2 and hit plus, it should say 3. If I hit minus, and it should say -1, and so on and so forth. This is basic maths that I need. So anyone have any doubts on the assignment? Two input fields, four actions, four arithmetic actions that based on the inputs that we are having. You guys should show it in something below, a really huge one, huge text view. You guys have to see, you guys have to show the result. Any questions? Do I need to explain again the assignment? Okay. So last time, anyone need any more clarification on the assignment? And make sure we are gonna get 30% from your final examination. 30% will be allocated from your assignments. So not only the final marks will be considered this time, 30% will be your assignments. So I will be in touch with Mr. Charmer, I think, if I can remember correctly. Yes, Mr. Charmer. Yes, with Mr. Charmer, and he will collect all your source codes and get in touch with you guys. So the deadline is the next lecture date. No, sorry, next week, Monday. Next lecture would be on Wednesday. So you guys have a week to complete. And I'll instruct Mr. Chamara on how you guys can proceed with collecting all the source code, and make sure we all are following a same Gradle file version. Otherwise, it's going to be hard to do automated testing on those things. Okay. Any questions with the assignment? 2 number fields, 2 input fields for arithmetic operations. Once you click one of the operations, you just have to show the result of it. Any questions, Nadishani? Any questions on that?
No, so it was clear.
Okay, great. So if anything is not clear, you guys can always ask Nadishan. Okay, all right. Let's move on. Let's move on with the rest of the lecture, and we'll go through one more iteration on the view model and what are the things. So remember the patterns and the anti-patterns. Always keep those things in mind. Otherwise, you will be messing up MVVM for sure. Okay. All right. Next, we will do something with the MVVM architecture. That is, so simply we have a view and a view model in here, and we have the basic mutable data. So we will deep little bit into the view model itself and why this is as mutable live data, or what are the alternatives that we can use, and why this is called value and all those things. Okay. All right. So let me minimize this. I hope you guys can see these things clearly. Okay, I will zoom it a little bit more. Okay. So first thing first, so we have the view model, and we are extending it from the life cycle of view model. But the result, the value that we are storing in here, the result, rather than we are having a simple double, okay, the result in here, number 1 plus number 2, it's going to be something, again, a double. Okay, but what we are doing in here, rather than putting it in a traditional double manner, we are wrapping it something called mutable live data. Okay, so what is mutable live data in this? So mutable live data, in the sense, there are two type of data available. That is mutable live data, and the other one is immutable live data. Okay, so the mutable live data in here, it simply means we have a double value in this scenario where we're going to store results. We have a double value. It's going to change throughout the time. Okay, it's going to change throughout the time. So we don't know when it is going to change. We just know it's going to change. Okay, so we have a value that's going to be called in here result, and it's going to change throughout time, but it's containing a double value. Okay, so when we are putting or we are assigning some values, we are changing or we are mutating the result, it's going to only accept double. Okay, that's why this generic is in place. So for example, now I want to say result dot value is into Randika or something like that. It is not allowed because Randika is a string, but we required a double. Okay, so we are restraining our type, saying, okay, we're gonna have a variable called results, and it's going to be a mutable live data. It's only accepting double at the moment. So by creating mutable live data, we are expecting this to be changed. So whenever we change this, whenever we are changing the mutable live data, whoever observing this, okay, whoever get observing this get a notification. That means they get notified, sorry, whenever we change the immutable live data. So that means result.value. This is the value, it's value it is currently holding. In this scenario, the default value we have put 0. For the first time when we are coming to the add button, the result.value is 0. Okay, the first time when we are coming to this is 0, and the result.value now we will change to the numbers that we are getting from this add method and assign it. Okay, that means we are changing the value, we are mutating the value, we are giving a new value, we are assigning a new value to the result variable. Result mutable live data is getting a new value. The value is number 1 plus number 2. Okay, this changes. So the mutable live data then says, okay, now the result value is changed. It is earlier it was for the first round it was 0. Now whatever the two numbers addition is here, now the result is changed. So the result value has changed. Whoever listening to this get that notification, hey, this value has changed, do whatever you want. Okay, so the thing happen within this view model observer is the same thing. So we are listening to the changes, we are changing that result value. Now we are observing it in here. So view model is having a variable called result, and we are observing whatever the changes that we are doing, and we are acting upon it. Okay, so this view model, mutable live data, is one way of doing that. Okay, so what are the where this mutable live data is coming from? So we did not talk that much into these classes, where they are coming from, what are these things are here for. Basically, to get an idea on that, we have to go always to the build.gradle files. So within the build.gradle file, you will find these dependencies. That's what I told you. When we are developing MVVM pattern, the MVV concepts, those are same. Those are it's going to be same for iOS, same for Android, but the way we accomplish these things is gonna different. So if you guys can remember, we can just simply have these things separated. This for the test, this is for Android test, and this is for unit test, and these are for the implementation. Okay, so these outcome packs are mainly for Kotlin. Sorry, these for the what do you call views, and these are live data, and yeah, these two also for material and constraint layout. These are also for UI purposes, and we have this lifecycle live data for our MVVM stuff. Okay, so we have this live data within our dependencies, which gives us the mutable live data class to mutate stuff. So this is the place, this is the implementation for observable pattern with live data. Okay, Android X live data. But live data, is it only the thing, only available state manipulation or observable pattern out there? No, it is not. That's what I mentioned. The concepts can be same, but implementations can be different. Even within the same application developers, same platform in this sense. So Android has this live data, You can use mutable live data to do the things, but it is not the only option. Different projects, different programmers, different architects, whoever designing this, they can use, they can um, uh, they can use different implementations to achieve the same goal. Okay, so there are uh, other alternative things that you can use. Okay, so if you guys really need um, other implementations, please check out Kotlin Flow, or we have something called state flows. So it is also something similar that live data does, but the implementation is a little bit different than what we are having right now. Okay, so we will use the state flow maybe on a separate video or separate lecture, so you guys can see that, okay, it's the same thing, it's going to be the same thing, but it's not using live data or mutable live data, but things like flows, or even things like flow scopes and flow combines. There are a lot of things that we can do. So live data is one of the implementations that you can do, and it is the easiest one. Okay, there are other options. Please remember those things. And there are one of the most common one that common alternative to live data that you guys will see is it is called RX Java. If I can remember. Yes, live data, or you can use RX Java. Okay, you guys can use live data in order to work with, or there is something called RX Java. The dependencies in here is going to be different, but most of the time the implementation where you do in our application is going to be same. So we can't rely on lifecycle methods on from the Android X, but it's going to be separate thing for things for RX Java. Okay, so remember, depending on the project, depending on the architecture, anyone can use any implementation as such. Okay, so why there are so many implementation on this? Well, that's because based on your application complexity, the reactive platforms that we are seeing can be different. Okay, so if I take something like RX Java, you won't see something like mutable live data, but something called observable and the data type. Okay, rather than using mutable live data, you will see something like observable, which is RxJS implementation. So RX Java implementation. So what sort of things that I can achieve by using RX Java rather than using live data? So the main difference that I have seen, RX Java has a lot of operators. Like it's literally, there is a lot of things that you can do with observables with when it is coming to um, RX Java. So in here, we don't use any operators right now, but for example, in this observable, this is using live data. But if we were to use something like RxJS, RX Java, we can apply some things like filters, mappers, and all those things. I think filters are something like take if filter. There are few operations available, but if you take RxJS, RX Java, there are a lot of operators that we can work with. Okay, so that's based on your expertise, based on your preference. You can change the view model implementation. Go with Kotlin Flow, RX RxJava, or live data. It's up to you. So how do you know which one is to use within your application? Well, that's something that you have to get your hands-on experience of. Okay. Create an application using mutable live data. Create the same application using RxJava. Create the same application using Kotlin Flow. You will see all are following the similar pattern, but the way they are using the operations that they are doing is going to be different. Okay, so make sure do a sample application on each of the reactive frameworks. So live data is from Android ecosystem itself, but RxJava is something else. Kotlin is from the Kotlin community. Like, there are a lot of alternatives that you need to try, and you will be surprised. So what are each and every view model functions they provide to you, and what are the things that you can do with the coding. It's not only on implementation, but also think about testability. Okay, when you are testing this, as you can see, when you are testing this view model, which we'll do in a later lecture on, when we are testing this view model, see how much support we get to test these add function. See how much support we can mimic this result mutable data. Likewise, make sure to go into more depth of these live data or view model changes that we are doing. See how much support they give in terms of implementation, testability, and maintenance. Okay, those are like things that you need to do from your experience. Okay, so make sure to check out the other competitors, because it's a viable option. Do not stick with view model or live data for all of your project's needs. There are drawbacks with the view model, live data as well. There are certain things live data cannot do, but other observable frameworks does support. Okay, so it's always to be good. Sorry, to you to be in the safe side and learn everything, at least most popular Kotlin Flow or RxJava in this scenario, to keep you in the safe side. Okay, I'm not gonna go with each and every ones. At least I will try to go with Kotlin Flow for the next one, but it's up to you to master the MVVM architecture and master at least one, so you know at least to create a good MVVM model in this scenario. Okay, right. So that's information why we have used mutable live data and what are all the other options that is available. Okay, so there is the implementation things like asynchronous programming as well as observable programming, or we call streaming. Okay, those are two different things as well. So make sure to do your research while you are doing your research on the view model implementation. Take a look at stream. What do you understand by a stream? Okay, note this down if you will. What do you understand by a stream? What do you understand by a synchronous data flow? Okay, what do you understand by asynchronous data flow? Okay, so based on those choices, based on your research, you will get more and more idea about okay, this project. Okay, based on my experience, based on the complexity of this application, we would go with mutable live data or live data. Okay, based on this scope or based on the requirement, okay, we'll be using RxJava to handle the view model. So that kind of knowledge only comes if you know what you are dealing with. Okay, streams, asynchronous data streams, synchronous data streams. I'm not going to explain each and every one. You guys need to do your own research and come up with your own definition. What do you understand by a stream? What do you understand by asynchronous stream? What do you understand by observer? There are a lot of things going on. Okay, so you guys first finish the assignment, then have a look around the terms and uh, terms that I have described in here. See what you can learn on each of these implementations or each of these view model alternatives. Okay. The reason I'm telling most of this is if you start your own project, of course you can decide we will go on live data no matter if there are any others. But say for example you were to maintain someone else's code, or you have to uh, work with existing code base. If they are not using live data, you can't say, we don't have live data. You should have Kotlin Flow. Let's do it in Kotlin Flow. That's not gonna work. Okay, you should know the alternatives. What are the pros and cons, and you have to adapt to it. Okay, as I mentioned, the providers, observers, and everything, those things are gonna be the same. Okay, the keywords will be a little bit different. We'll be using observer live data. In Rx Java, you'll be using observers. That's it. Concepts are going to be same. All right. Okay. Yeah. So we have talked about live data, why it is mutable, why it is the way it is, the empty patterns. Next time, what we will do is we will have a look around what we call the model. Okay, we have not touched the model. We will connect the model in here, but make sure to follow along. Make sure you guys um, get into the retrofit stuff first. If you guys can't remember retrofit or room or anything like that, please make sure you guys follow those things first. Otherwise, the model part will be a little bit confusing if you don't know the terms and everything. So please make sure you check that out. And if time permits, on the next lecture, we will be continuing on how we can write test on each of these separate layers and why it is better than testing everything in our view. Okay, anything else with the dependencies or anything else you guys need to have to talk, or anything you guys need to get more information on? Okay, I hope everybody got the idea. All right, let me stop sharing and